Here's our code from VS Code being plugged into the ESP32. That's how we upload our code to control everything in our project. Our ESP32 is hard-coded to hardwired to everything else. For our next major hardware component is the WS2812B LED. Each is powered by 5 volts. The bits are sent through the data line to change the color. Each is individually adjustable and not dependent on the previous LED. We could chain however many of these we want in a row. With our project, we need 64 LEDs. Here we can see LEDs cycling through the colors. Here's purple, and then turned off.
Here we have the L298N motor driver. It's powered by 12 volt and allows for motor control in both directions using GPIO pins from the ESP32. Here we have the 12 volt high torque motor. We can see when we power the motor that the shaft is able to go forward and backward. This is how our system can go up and down depending on the circumstance.
The next major component in our system is the solenoid with its switching circuit. The switching circuit consists of a transistor being signaled by the GPIO pin sent to the base. If the signal is high, then the solenoid will be activated. If the signal is low, then the solenoid will be deactivated. Here we can see the 2 solenoids. When powering the second one, it powers, then deactivates. The first one powers, deactivates, and we can see here both will be able to be activated.
And this is the slip ring. It's used to connect the rotating wires to stationary wires connected to the MCU. And we can use this to power and control the solenoids. We can see when the solenoids actuate, they will enter the holes on the gear. And by activating a solenoid and rotating the motor, we can either drive up or down the racks/towers. We see here with the solenoid activated and motor on, it can push up or pull down the rack. We can activate one or the other or both at the same time. And this is the height control system. So we can push the rack up using the solenoid, and once we deactivate the solenoid, the rack will remain in its position. And to pull it down, we activate the solenoid and turn the motor the opposite direction. We can also do this using 2 solenoids at once. So we activate both solenoids and drive the racks upwards. This can increase the refresh rate on our 3D grid. We can also pull them down at the same time. And this is the final demo using all components to show a complete working project. We have the LEDs, the slip ring, the solenoids, and the motor all working together to display different dimensions.